Hello, in this video let's discuss the arrangements with the forbidden positions. Consider the description. Suppose m objects are to be arranged in n places where n is greater than or equal to m, and suppose there are constraints under which some objects cannot occupy certain places. Such places are called the forbidden positions for the said objects. The number of ways of carrying out this task is given by the following rule. So this is the rule, and here S0 is calculated as n factorial and Sk is nothing but each one of the S1, S2 and S3. So if you consider the board, here the number of objects can be taken as rows and number of places can be taken as the columns, and here number of places is the n value. Suppose there are 4 columns, then n is equal to S0 is equal to 4 factorial. So Sk is nothing but S1, S2, S3. So if you have S1, S1 is equal to should be calculated, S2 should be calculated, and S3, and all this should be again taken as an input for the n bar. So let's understand this thoroughly by using an example. Consider the example: an apple, a banana, a mango, and an orange are to be distributed to 4 boys B1 and B2, B3, B4. The boys B1, B2 do not wish to have apple. Boy B3 does not want banana or mango, and boy B4 refuses the orange. In how many ways the distribution can be made so that no boy is displeased? So again, let me consider the board in which the number of objects are 4, that is apple, banana, mango, and the last one is orange. Same way we have the 4 position, that is boys B1, B2, B3 and B4. So according to the question, boy B1 and B2 do not wish to have apple, so shade that part. They don't want to have the apple, so that is the forbidden position. And boy B3 do not wish to have both banana and or mango, so both are shaded, and boy B4 does not want to have the orange. So if you observe the board, so this board consisting of 3 disjoint subboards C1. So this is C1, and here it is the C2, and finally it is C3. Now calculate the polynomial for all the 3 boards. So for R of C1x, the n1 value is equal to 2, and n2 cannot be calculated because we have only 2 squares. If you place first pan over here, the second pan cannot be placed over here. So R of C1x is equal to 1 plus 2x. And same way R of C2x, again it have got only 2 squares. So C2x is equal to 1 plus 2x. And R of C3x, here we have got only 1 square. For the trivial case, the equation is 1 plus x. Now by using the product formula, we can combine all of them and find out the Rook polynomial for the entire board for the forbidden position. So R of Cx is equal to, here we have got 1 plus 2x into 1 plus 2x, that is 1 plus 2x, that is 2 times, so 1 plus 2x whole square into 1 plus x. So we can derive 1 plus 2x whole square as it is in the form of a square plus 2ab plus b square. So 1 plus 2ab, that is 2 into a into b, 2 into 1 into 2x, that is 4x, plus 2x whole square is 4x square, into 1 plus x. Now each one of the components should be multiplied. So multiply with 1 plus 4x plus 4x square, plus multiply with x plus 4x into x is again 4x square, plus 4x square into x is 4x cube. Now the answer is given by 1 plus 4x into x, 4x plus x is 5x, plus 4x square plus 4x square is 8x square, plus 4x cube is the required Rook polynomial. Now consider this equation: 1 plus 5x plus 8x square plus 4x cube. Let me write over here: 1 plus 5x plus 8x square plus 4x cube. Here, as we denoted, if you take the equation, the general equation for the R of Cx, it will be in the form of 1 plus n1 sorry 1 plus r1x plus r2x square plus r3x cube so on up to rn, so on up to rn into x power n. So same way here r1, if you compare the equation 1 plus 5x, so r1 value is equal to 5 and r2 value is equal to, compare these two, r2 value, compare these two, r2 value is equal to 8 and by comparing these two r3 is equal to 4. So we have got r1 5, r2 8 and r3 4, and the equation for the forbidden position is given by n bar is equal to s0 minus s1 plus s2 minus s3 so on. Now we have got only three positions r1, r2, r3, hence I have taken it as s0 minus s1 plus s2 minus s3. So now we need to find out what is s0, s1, s2 likewise. S0 is calculated as s0 is equal to n factorial. N factorial is nothing but the total number of places. In this given question, the total number of places are nothing but the total number of boys. So there are 4 boys, hence s0 is equal to 4 factorial, that is equal to 24. Now we have calculated s0. Same way s1 should be calculated, s2 and s3. So we have the formula sk is equal to n minus k factorial into rk. So here we need to calculate s1. So I'm going to take it as s1 is equal to, the n value is 4. We know n is equal to 4 because there are 4 boys. So 4 minus the k value is 1 because we have taken for s1. So 1 factorial into rk, r1. So that is equal to 4 minus 1 is 3 factorial into r1. We know r1 value is 5. So if you simplify this, we will get it as 30. So same way if you calculate s2, we will get it as 4 minus 2 factorial into r2. If you substitute, we will get the answer as 16, and same way s3 can be calculated as 4 minus 3 factorial into r3. We know the r3 value is 4. So if you simplify, we will get it as 4. Now substitute all this value into the equation n bar is equal to s0. So we know s0 value is 24 minus s1 value is calculated as 30 plus s2 value is calculated as 16 minus s3 value is 4. If you simplify this, 24 minus 30 plus 16 minus 4, we will get the answer as 6. So there are totally 6 ways of positioning the forbidden, that is placement in the forbidden position. So this is how you need to calculate the arrangements in the forbidden, arrangement of the forbidden positions. So this completes with the solution. Thank you.